Hi, good morning, guys. We'll try to do uh, the example wherein, or the workflow wherein we would generate a RLC block in from a Simulink model using a Simscape library, a Simscape SimPower system specialized technology blocks. But one thing that you would notice is that the blocks here, or the parameters here, say resistance, inductance, and capacitance, cannot be uh, tuned whenever the code is already when the model is already deployed into a DLL file, because I think the back end of the blocks here is actually something what we call as state space models. So what we can do in order to do a tunable parameters is that rather than using the standard blocks for sim power systems or simscape power systems specialized technology, is that we use the toolboxes for the newer ones, wherein it's probably let's say if I go to foundation library, then I'm just going to get a resistor, and then the values or the parameters that we place in here is like a variable, but we change it into instead of using compile time, we will change it to runtime. And this is where the limitation we're in. If I have different values for my parameters, then I cannot do that. However, if you want to do some workarounds, then we can generate as many models as possible with different parameter values and make them in make this parameter values as inline parameter values. Then it can be done, but that's a lot of models. Let's say we were going to do something like a permutation of all the blocks that you use, but let's say we just build a DLL file with a inline variables. Let's say I'm just going to make it standard, wherein I have this uh, resistance is 1, inductance is 1, capacitance is also 1. So once I have this one, let me just explain to you what the model is, and it's just a very simple RLC series circuit. I have an input. I have two outputs wherein it would measure the voltage and the current, and then we would have this continuous power GUI block. So once we have this model, I think we just need to run through with the program code that is being done already by MathWorks, wherein it's actually an example. So the first thing that we need to do is maybe run through the script, and let's try to explain one by one. So it's actually just an automation script, but what it's actually doing is that we change the solver to a ODE 14x. So and then change the it to a fixed step solver. So we're not going to use the standard how do you say it, variable solvers that we normally use, but we need to consider that we are actually trying to generate C codes and then compile them to DLL, and variable step solver is not available for that, so we cannot use it. So hence, instead of using variable step solvers, we're going to use fixed step solvers. And the problem with regards to fixed step solvers is that the the simulation, or let's say the time step, is now being constrained to a fixed value, wherein in the variable step solver it can do something like I'm going to use a time step of 1, then on the next time step I'm going to use 0.001, and it would actually play this the value here would actually play a great role into where is my simulation correct or not. But from my example here, I'm just going to use what was provided by the continuous GUI. But definitely we can compare at the end on which would be the best value to use. So let me just close this one down and then run through with this ERT shared library underscore setup .m. So let me just run this program code, and it will actually generate a model which is now named as RLC underscore codegen.slx. And what we need to do next is that we go for the script wherein it has this RLT shared library underscore build. It's actually going to open the model, right? Let me just run through with model integrity and verification. And then there's additional steps that is not being included in the script. So I'm going to do this manually. So just try to go through it, watch and take note on this one. So I'm going to open the model, and the model is our name is RLC underscore cogen. And what I'm going to do first is that I'm going to change the Power GUI to become discrete. And then there is this default value being set, but let me just take this one. I'm just going to copy this one and click apply. And then I'm going to go to the configuration parameters. So once I'm in configuration parameters, the solver options is being set by the script. I'm going to change the fundamental sample time to what was set in the Power GUI block. I'm going to click apply. I'm going to go to the coverage, to the code generation tab. So we can see here that the system target file is actually using ERT underscore shared library.tlc. And we need to go through the interface, and then we might need to click on continuous time or whatnot. But one thing that we need to go through is that in the advanced parameters, there is this tab for non-inline S functions. So most of the blocks of the specialized technologies are S functions, and we need to check this block out. All right, and then we click apply and click OK. So once we have this one, I'm just going to save this one and then close the model, right? And then I'm just going to run through with this create DLL section. So what MATLAB will do now is that it will actually create or generate C codes and create a DLL. And the next thing that we need to do is that we're going to use the function load library, wherein it actually brings in all the needed source files and header files to be able to formally call the library. So from here, I'm just going to run through the section, but take note on the things that was added with regards to the source codes and the header files for the blog. So it's actually part of the MATLAB folders or search path. So once I'm here, I'm just going to click run in advance.